Welcome to Core of Space. Today, we're diving deep into Pluto, our once ninth planet turned dwarf world at the edge of our solar system. From its heart-shaped plains to mysterious haze and cryovolcanoes, today's adventure will uncover everything that makes Pluto extraordinary. Let's begin. Pluto 101, everything you need to know. Welcome to Core of Space. Today, we're exploring Pluto, the mysterious little world that was once our ninth planet. What is Pluto really? Why was it demoted? And what makes it so fascinating even today? Let's find out in just 4 minutes. Discovery and naming. Pluto was discovered in 1930 by American astronomer Clyde Tombaugh at the Lowell Observatory. The name, Pluto, was suggested by an 11-year-old girl from England, Venetia Burney. And yes, it's named after the Roman god of the underworld. What kind of planet is Pluto? For 76 years, Pluto was called the ninth planet. But in 2006, the International Astronomical Union redefined what a planet is. Pluto didn't make the cut. Why? Because it hasn't cleared its orbit of other objects. Planet Criteria, IAU. Orbits the Sun white heavy check mark. Is spherical white heavy check mark. Clears its orbit crossmark dwarf planet. Physical features. Even though it's tiny, only about 2/3 the size of Earth's moon, Pluto is full of surprises. Its surface is covered in frozen nitrogen, methane, and carbon monoxide ice. It has mountains made of water ice, and a giant heart-shaped glacier called Sputnik Planitia. Surface temperature, -230 degrees Celsius -382 degrees Fahrenheit snowflake. Pluto's rotation is weird too, it spins on its side, just like Uranus. And a day on Pluto lasts over 6 Earth days. Pluto's moons. Pluto has 5 known moons, the largest is Charon, which is so big it's almost a twin. In fact, Pluto and Charon orbit each other like a double system. From its icy surface to its mysterious past, Pluto may be small, but it's full of big questions. New Horizons, the historic flyby of Pluto explained. NASA's bold mission that gave us our first ever close look at Pluto. What did it find? And how did it change space science forever? Let's find out. The mission begins. New Horizons was launched by NASA in January 2006, with one main goal: to explore Pluto and the Kuiper Belt. Traveling at over 58,000 kilometers per hour, it became one of the fastest spacecraft ever launched. On its way, it got a gravity boost from Jupiter in 2007, which helped it reach Pluto faster, and gave scientists bonus data about Jupiter's moons and magnetosphere. The Pluto flyby. After nearly 9.5 years, New Horizons finally made its closest approach to Pluto on July 14, 2015, passing just 12,500 kilometers above its surface. In just a few minutes, it changed everything we thought we knew. It captured over 50 gigabytes of data, including detailed images of Pluto's icy mountains, massive glaciers, and that famous heart-shaped region called Sputnik Planitia. Pluto's mountains are made of solid water ice, taller than the Rockies. Big discoveries. New Horizons showed that Pluto is not a dead world, it's geologically active. Scientists discovered hints of cryovolcanoes, glaciers that move, and even signs of a possible subsurface ocean beneath its icy crust. It also revealed that Pluto has a blue, layered atmosphere made mostly of nitrogen, with haze reaching over 200 kilometers high. It's thin, but complex and beautiful. After Pluto, New Horizons kept going, and in 2019, it flew past another distant object called Arrokoth in the Kuiper Belt. It's still sending back data today from the edge of our solar system. The Heart of Pluto, Tombaugh Regio explained. Welcome back to Core of Space. Today, we're exploring the most iconic and mysterious part of Pluto, a giant heart-shaped region known as Tombaugh Regio. It's more than just a symbol of Pluto's charm, it tells us a story of glaciers, geology, and perhaps even a hidden ocean. let's dive in. What is Tombaugh Regio? Tombaugh Regio is a large, bright area near Pluto's equator. It was first seen clearly by NASA's New Horizons spacecraft in 2015. The region is shaped like a heart and stretches over 1,600 kilometers, almost the width of the United States. On-screen fact. Named after Clyde Tombaugh, Pluto's discoverer in 1930. Narration continues. It's divided into two lobes, the western lobe, called Sputnik Planitia, and the eastern lobe, a more rugged, mountainous area. But most of the action happens in Sputnik Planitia. Sputnik Planitia, an icy mystery. Sputnik Planitia is a massive, icy plain made mostly of nitrogen ice. What's fascinating is that this plain isn't flat and boring, it's full of polygon-shaped patterns, which are actually convection cells, like frozen lava lamps. These patterns form because heat from Pluto's interior causes the nitrogen ice to slowly rise and fall, making the surface look like it's in motion, even though it's frozen. Sputnik Planitia is also incredibly young. There are almost no impact craters, suggesting it's less than 10 million years old, a baby compared to Pluto's 4.5 billion year history. A giant glacier and possible ocean. The entire western lobe of Tombaugh Regio is like one massive glacier. Nitrogen and carbon monoxide ices flow slowly across the basin, pulled by Pluto's weak gravity. But why does this glacier sit exactly where it is? Scientists believe that Sputnik Planitia may be hiding a liquid water ocean beneath its crust. The weight of that underground ocean could explain why the ice basin formed and why Pluto's spin axis shifted over time. This theory is called true polar wander. Pluto's heartbeat, climate and atmosphere. Pluto's heart doesn't just sit there quietly, it beats. Well, not literally, but it drives a seasonal nitrogen cycle. During Pluto's long year, nitrogen ice evaporates from one side of the heart, and even now, scientists are still analyzing data from New Horizons. There's a chance Pluto's icy heart is still active today, moving, shifting, and possibly hiding clues about life-supporting conditions deep inside. Future missions could confirm if Pluto really has a subsurface ocean, and what that might mean for other icy worlds in our solar system. Mountains and cryovolcanoes on Pluto, what did New Horizons discover? Welcome to Core of Space. Today we're going to explore Pluto's stunning mountain ranges and mysterious icy volcanoes, also known as cryovolcanoes. Yes, this distant dwarf planet is far from lifeless, in fact, it's geologically active. Pluto's icy mountains. When NASA's New Horizons spacecraft flew past Pluto in 2015, scientists were shocked to find mountains taller than the Rockies, made entirely of water ice. On Pluto, water ice acts like rock because it's so cold, around -230 degrees Celsius. Snow-capped mountain Norgay Montes and Hillary Montes, up to 3 to 4 kilometers tall. These mountains are found along the edge of Pluto's heart-shaped region, Tombaugh Regio, right next to the icy plains of Sputnik Planitia. Their sharp peaks and rugged structure tell us they're geologically young, likely less than 100 million years old. Cryovolcanoes, icy eruptions. Even more surprising than the mountains were Pluto's cryovolcanoes. Volcanoes that don't erupt lava, but instead spew ice, nitrogen, and possibly water mixed with ammonia. Wright Mons is 150 kilometers wide and over 4 kilometers high, with a massive depression in the center, just like a volcanic caldera on Earth. Scientists believe this could be the site of an ancient cryovolcanic eruption. These icy eruptions may have happened millions of years ago, or they might still be happening today. That would make Pluto an active world, even at the edge of the solar system. What powers Pluto's activity? But how is Pluto active when it's so cold and far from the Sun? Scientists think heat from radioactive elements inside Pluto's rocky core, along with possible pockets of liquid water beneath its surface, could drive this activity. This means Pluto may still have an underground ocean, and that these cryovolcanoes could be a way for that ocean to interact with the surface. It opens up fascinating questions about habitability and geological evolution. Pluto's alien landscapes, bladed terrain and methane dunes explained. Welcome back to Core of Space. When NASA's New Horizons flew past Pluto in 2015, it captured bizarre and beautiful landscapes. Today, we're exploring Pluto's bladed terrain and mysterious methane dunes, two features that are unlike anything on Earth. Bladed terrain, aka icy knife edges. One of Pluto's strangest features is a region called Tartarus dorsa, covered in long, sharp ridges called bladed terrain. These blades are made of methane ice, and they stretch for hundreds of kilometers. Scientists believe these icy blades were formed through a process called sublimation, where solid methane ice turns directly into gas due to sunlight. Over millions of years, this sculpts tall, razor-like structures pointing toward the sky. These formations are so alien that their closest cousins might be found, not on Earth, but on Jupiter's moon Europa, or even on Triton, Neptune's moon. Methane dunes. Another shocking discovery: sand dunes on Pluto. Yes, dunes, made not of sand, but of tiny methane ice grains. They were found along the western edge of Sputnik Planitia, Pluto's heart-shaped glacier. How are dunes possible with such a thin atmosphere? Pluto's gravity is low, but it still has gentle winds, around 30 to 40 kilometers per hour, strong enough to lift and move fine methane particles. These dunes are a sign that Pluto's surface is active and changing, shaped not only by ice and geology, but also by wind and atmosphere. Why it matters? Both the bladed terrain and methane dunes show that Pluto is not a frozen dead world. It has complex surface processes, from sublimation to wind erosion, happening even at the edge of the solar system. Studying these terrains helps scientists understand similar icy bodies, like Triton, Europa, and even distant exoplanets. From knife-edge ice ridges to dunes of frozen methane, Pluto continues to amaze us. Pluto's atmosphere and hazy skies, what lies above the surface? Welcome to Core of Space. Today we're not exploring Pluto's surface, we're going above it. From a thin envelope of nitrogen to mysterious blue hazes made of organic particles, Pluto's atmosphere is one of the most surprising in the solar system. Let's explore what it's made of, how it behaves, and why it might be disappearing. Pluto's thin atmosphere. When NASA's New Horizons spacecraft flew past Pluto in 2015, it saw something incredible: a glowing atmosphere surrounding this icy dwarf planet. Even at nearly 6 billion kilometers from the Sun, Pluto has an atmosphere made mostly of nitrogen, with traces of methane and carbon monoxide. Milky Way atmosphere composition: 98% nitrogen, 1.5% methane, small amounts of CO. But it's extremely thin, about 100,000 times less dense than Earth's atmosphere. Still, it's enough to create winds, haze layers, and even weather patterns. Visuals. Cross-section of atmosphere with labeled layers. Mysterious haze layers. One of the most beautiful and unexpected discoveries was Pluto's blue haze, a layered, smoky sky that looks almost like twilight on Earth. These are not clouds, they're made of tiny organic particles called tholins. When sunlight hits methane high in Pluto's atmosphere, it breaks apart the molecules. These fragments react with each other and form heavier hydrocarbons like ethylene and acetylene. These eventually clump together into tholins, which fall slowly to the surface. These particles scatter blue light, just like Earth's sky, which is why Pluto's atmosphere appears bluish from space, even though the particles are reddish when they land. A living, changing atmosphere. Pluto's atmosphere isn't stable, it changes with the seasons. Pluto takes 248 Earth years to orbit the Sun, and its axis is tilted by over 120 degrees. This means extreme seasons that last for decades. During its long summer, sunlight heats up Pluto's nitrogen ice, causing it to sublimate and form a temporary atmosphere. In winter, temperatures drop so low that the gases freeze and fall back to the surface, thinning the atmosphere again. Pluto's mysterious moons and the kiss and capture origin theory. Welcome back to Core of Space. Today, we're diving into the mysterious world of Pluto's moons, especially its largest moon Charon, and a fascinating idea about their formation, the kiss and capture origin theory. Let's get started. Pluto's moons, a quick overview. Pluto isn't alone out there. It has 5 known moons. Charon, the biggest and closest. And 4 smaller ones, Styx, Nix, Kerberos, and Hydra. Full moon Charon is so big it's about half the size of Pluto, forming a double-planet system. Charon is so massive compared to Pluto that the two actually orbit a common center of gravity outside Pluto's surface, something we don't see with any other planet and moon in the solar system. The kiss and capture origin theory. One popular theory about Charon's origin is called the giant impact hypothesis, similar to how Earth's moon formed. It suggests that a massive object slammed into Pluto billions of years ago, and the debris eventually formed Charon. But there's another idea that's gaining interest, the kiss and capture theory. According to this, Pluto and Charon were once 2 separate icy bodies in the Kuiper belt. Over time, they passed close enough that Pluto's gravity captured Charon in a kind of slow-motion embrace, at the kiss that turned into a permanent orbit. Dizzy kiss and capture equals gentle gravitational capture between 2 Kuiper belt objects. This would explain why Pluto and Charon are so similar in size, composition, and orbit, and why they rotate in perfect tidal lock, always showing the same face to each other. What about the other moons? Visuals: zoom in on Nix, Hydra, Kerberos, and Styx orbiting in complex paths. The 4 smaller moons, Styx, Nix, Kerberos, and Hydra, might be leftovers from the same event, or they may have formed from debris after the Pluto-Charon pairing. Their orbits are highly chaotic, and they rotate unpredictably, like spinning tops in space. These tiny moons add mystery to the Pluto system, and may hold clues to the early days of the outer solar system. Pluto's moons tell a dramatic story of collisions, capture, and cosmic dance. If you enjoyed this space mystery, like the video, subscribe to Core of Space, and let us know, which moon would you visit first?